Hi students. So today we'll discuss the topic enthalpies for different types of reactions. That is, you know that there are many reactions occurring around us. So we'll study about the enthalpy change of these reactions. That is enthalpy change for different types of reactions. So in that, first one is standard enthalpy of combustion. So you know that what is combustion? Combustion means when a substance, when it reacts rapidly with oxygen and it will gives out heat, so that is combustion. Or you can say it is just heating of a substance. It is combustion. It uses oxygen and then it will gives out heat energy, so that is combustion. So the first one is standard enthalpy of combustion. And you know that when a substance burn, or when a substance is undergoing combustion, heat energy is given out, isn't it? So when a reaction, when it gives out heat energy is called a exothermic reaction, isn't it? When a reaction, when it gives out heat energy, it is an exothermic reaction. So all the reactions which undergo combustion, that is heating, all combustion reactions are exothermic in nature because they gives out heat energy. Now, standard enthalpy of combustion, it is defined as the enthalpy change per mole of a substance when it undergoes combustion and all the reactants and products being in their standard states at the specified temperature. That is, when 1 mole of a substance undergo combustion. Okay, when 1 mole of a substance, when it undergo combustion, what is the change in enthalpy? That is called as the standard enthalpy of combustion. Okay, and for that, the reactants and the products, okay, reactants and the products, they should be in their standard states. Okay, so reactants and products, they should be in their standard states, and when 1 mole of a reactant undergo combustion, the change in enthalpy is called the standard enthalpy of combustion. Okay, now the symbol for standard enthalpy of combustion is what you see in the image, that is delta CH, and you can see a superscript which indicates standard state. So all the substances should be in their standard states, and you can see the symbol, that is delta CH with a superscript. This is the symbol of standard enthalpy of combustion. Now if you take an example, this is an example of combustion of glucose. Okay, you can see glucose C6H12O6. When it reacts with oxygen, that is combustion, it gives out carbon dioxide and water molecules, 6 water molecules. Okay, so this combustion of glucose, you can see the enthalpy change, that is delta CH, it is given as minus 2802 kilojoules per mole. So the combustion of glucose, it gives out 2802 kilojoules per mole of heat energy. Okay, and you can see there is a minus sign written which indicates that the reaction is exothermic. When the change in enthalpy, when it is minus, it is exothermic. When it is plus, it is endothermic. So all the reactions which undergo combustion, they are exothermic in nature because they gives out heat energy. Okay, so this is an example for standard enthalpy of combustion, and you can take many other examples also. For example, 1 mole of butane, the combustion of 1 mole of butane is also an example for standard enthalpy of combustion. Now the next topic is enthalpy of atomization. That is the second type of reaction, that is enthalpy of atomization. Okay, so you can see an example here. The following example here, you can see dihydrogen, that is H2 dihydrogen. What is happening is, you can see dihydrogen, it gives 2H, that is hydrogen molecule, it breaks down to give hydrogen atoms, isn't it? H2 means it is a molecule, so it breaks down to give a 2H, that is 2 hydrogen atoms. Okay, so how is it happening? It is happening when H bonds, that is H2 means it is hydrogen with a bond hydrogen, isn't it? When that bond, when it breaks, you will get 2 hydrogen atoms. Molecules, when it breaks down, you will get atoms, isn't it? So here hydrogen bond hydrogen in dihydrogen, it is breaking to give 2 hydrogen atoms. So the enthalpy change in this process, it is known as the enthalpy of atomization. That is, enthalpy change on breaking 1 mole of bonds completely to obtain atoms in the gas phase is known as enthalpy of atomization. That is, when 1 mole of a bond, okay, considering 1 mole of a bond, when it breaks down completely to give atoms in gas phase, then it is known as the enthalpy of atomization. That is, 1 mole of a bond, when it breaks completely to get atoms in gas phase, the change in enthalpy during that process, the change in energy during that process, it is known as the enthalpy of atomization. That is, breaking of bonds. Okay, the change in enthalpy during breaking of 1 mole of a bond to get products in gas phase, that is known as the enthalpy of atomization. And the symbol is given, that is delta A, that is small a h with a superscript. So all substances should be in their standard states. Okay, so this is the symbol of enthalpy of atomization. Now you can see there are many other examples also for enthalpy of atomization, where the products should be in the form of atoms and in gas phase also. Okay, now if you consider this reaction, that is sodium in solid phase, it is giving sodium in gas phase, isn't it? Sodium in solid S phase, it is giving sodium in gas phase. Okay, so the change in enthalpy, that is enthalpy of atomization, it is also given. So here in this case, the enthalpy of atomization, it is same as the enthalpy of sublimation. You know what is sublimation? That is solid directly converted to gaseous state, that is sublimation. So here you can see sodium is in the solid state, then you are getting the product, that is sodium is in the gaseous state, isn't it? So it is sublimation, solid to gas, it is sublimation. So here enthalpy of atomization and enthalpy of sublimation both are same. Okay, thank you.